Okay, folks, in this presentation, I'm going to show you how to calculate the sample variance from a frequency distribution table. One of the confusion among the students is the group data and an ungrouped data. Ungrouped data is a bunch of numbers, just like this one. You can see here, it's not grouped in any form or shape. However, the same data set can be organized in a group form. For example, you can see that 12 occurred in this ungrouped data set 1, 2, 3, and 4 times. So in the frequency distribution table, you can write down just 12, and then 4 means it appeared in the data set 4 times. And in that way, you can organize all the numbers. This is called frequency distribution. There is more than one way that you can construct the frequency distribution. In this case, I have just taken a very simple example. So to compute the mean for the frequency distribution table, I'm assuming this is a sample data set. This is the formula that you're going to use, sum of fx divided by sum of f. So sum of f means you add all of these numbers. And to do this, you can just use the summation sign right here. So if you click and enter, that will give you 24. So you have 24 observations altogether in this data set, in this frequency distribution table. Okay, so to compute sum of fx, you have to compute fx column first. And the way you do it, you say equal to f times x, enter. Now I have given the cell reference. Now I do not need to type all of those. I will just take my cursor to the right bottom corner of the cell, and the moment the plus sign appears, I hold the left mouse key and then drag it down, and then when I'm there, I release the mouse key and all of the calculations are done. So if I want to check any of the calculation, I take the cursor right there and click, and when the cell is there, I push F2 button, and then I will see the formula D19, C19. D19 is this, D19 is this 4 times 17, and the answer is 68. So now if I take the sum of this column, I'm going to get fx. So how I'm going to get the sum? I'm going to write down equal to sum parenthesis, and then I'm going to highlight the entire column. Parenthesis closed. Now for x bar, I'm going to use this formula. Now you can see I have the numerator, I have the denominator. So I can say here equal to, this is my numerator, divided by, which is slash, the denominator, x bar. So 14.75 is my sample mean. Now, to get the variance, I'm going to use this formula. Now you can see the numerator is sum of f times x minus x bar square. So before I take this sum, I have to compute these factors first. So here is this factor. So the way I'm going to write is equal to f times left parenthesis x minus 14.75. You can see I'm typing 14.75. I'm not giving the cell reference. And the reason is I want this 14.75 to be fixed for all of these numbers. Now to the power 2, you're going to type shift 6, which is hat, and then 2. That will be the to the power of 2. Enter. So you have that number. And I'm going to do the same. I'm going to take the same action here. You can see the plus sign appeared. I hold the left mouse key. I drag it down. So now I have f times x minus x bar column right here. I can double check by pushing F2. I can see the formula D18, which is D18, times C18 minus 14.75 to the power 2. Okay, now to compute S squared, I have to sum this column and then divided by n minus 1. So I'm going to say equal to SUM, and this column right here, I'm going to add this, parenthesis closed, and then divided by parenthesis 24 minus 1. I could have just said 23, or I could have just typed rather 23, but I just wanted to show you the formula that you have to have a parenthesis for 24 minus 1. Enter. So this is your variance, sample variance. So the sample standard deviation will be the square root of this. So I say equal to SQRT, this is the formula for square root, left parenthesis, and then cell reference, right parenthesis, enter. So this is the standard deviation of the sample data set. You have to remember that there is another variance that is called population variance that is represented by sigma square. If you have a population data and you compute the variance from the population data, that will be sigma square. But in this case, you have the sample data as I have defined before. That's why it is S squared. And another difference is when you compute the variance sigma squared, the divisor will be n, not n minus 1. Okay? So there you go. You have all the steps that you need to calculate the sample variance from the frequency distribution table. Okay? Thank you.